Hey everyone. So in this video, I'd like to talk about circles. So circles, they're core to trigonometry, and now that we've talked about right triangles and the distance formula, we really have the tools to more concretely discuss this topic of circles. And so I want to begin by defining what a circle is. And so I'm sure you have some familiarity with this word circle, and I want to ask, what comes to your mind when you think of a circle? You might have the word round in mind, or symmetric. And if we use those words alone, it doesn't quite give us this idea of a circle because this image on the left, for example, we know that's not a circle, but this is pretty round and pretty symmetric. But this is not a circle. Right? We need something a little bit more. We need to be more precise. And so a circle, it's actually the set of all points that are the same distance away from a particular center point. Right? So here, when we say the same distance away from a center point, usually that same distance away, we refer to it as the radius. Right? So back in our picture above, here might be where that center point is. And the radius is this distance here. Right? Every point is that same distance away, a radius distance away from the center. And one thing I want to point out is that this center, this center point, although it's very important when it comes to defining a circle, it's actually not a point that's on the circle. It's not meant to be a point on the circle. And so we'll often want to get a hold of the points on a circle, and really the most natural way we can do this is with an equation. And so here I've got a circle drawn out, and I want to find the equation of this circle. And so the first thing we really want to notice is the center. It looks like it's the point -2, 1. And the radius, we can see, it's not always so clear what the radius is, but in this picture we can tell from the point 0, 1 that the radius is 2, right? That point's 2 units away from -2, 1. And so how do we find the equation of a circle? Well, the core idea is this using the distance formula. Right? The definition of a circle is a set of points that are the same distance away from a center point. It feels like the distance formula should sort of be in this picture here. And really the idea is that any point that's going to be on the circle must satisfy this sort of distance formula equation. Right, that point is the radius distance away from the center. Right, and so here recall that the distance formula, it's a variation of the Pythagorean theorem, but if I have 2 points, x1, y1, and x2, y2, then the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Right, so that's the distance formula, and to fit this idea of a circle into this picture, we're saying that all the points on the circle, it should be a distance of 2 away from this point -2, -1. So I'm asking that the distance between a point x, y and the point -2, 1, I'm asking for that distance to be 2. Any such point that satisfies that condition is a point on the circle, right? So it should satisfy this equation that 2 is equal to the square root, right? The distance 2 is equal to the square root of x minus -2 squared plus y minus 1 squared. And usually when we're dealing with an equation for a circle, right? This is actually the equation for that circle. We're not such a big fan of incorporating the square root into the picture. We tend to square both sides. So we have this 2 squared is equal to x minus -2 squared plus y minus 1 squared. And maybe I'll simplify this a little bit further, right? So this comes out to be, this is 2 squared is equal to x plus 4 squared plus y minus 1 squared. And so this is the equation of our circle. And so one thing I want to point out is that we can actually see the two key characteristics, two key features of our circle in this formula. And it's maybe a little bit clearer up here. Right, so notice that here we see that radius. It's being squared, but we very clearly see it in our equation for a circle. And then we also see that the center, right, sort of being subtracted away in this equation. And so here, notice that we get this positive, oh, why did I write positive 4? Sorry, that got a little bit ahead of myself. This should be positive 2. Right, so we see that our center point, the signs get reversed in the equation, but that's okay. That's kind of coming from the fact that there's subtraction in the distance formula. Right? This is just another variation of the Pythagorean theorem. And so if you ever really forget the equation of a circle, where it comes from, you can kind of just dig back to the Pythagorean theorem and to the distance formula. And here, maybe let's go ahead and verify that this is truly an equation to the circle by plugging in one of the points on the circle and seeing that it makes the equation true. Right? That's what should be the case for any equation and its graph, is that points on the graph of the equation should make the equation true. And so let's test one of the points. Maybe let's test the point we noted earlier, this point 0, 1. Right? That's a point on the circle, and so it should make the equation of that circle true. So let's check. Right, so here we just want to check that 4, is that going to come out to equal the right-hand side when we plug in the point 0 for x, 1 for y. So right, 0 plus 2 squared plus 1 minus 1 squared. Right, and so what we get here is, when we still have 4 on the left, 0 plus 2 squared, that gives us 4 plus 1 minus 1 squared, so that's 0. This is indeed true, right? So this is a point on the circle based on just using our equation here. It should make us feel a little bit more confident about our equation. And this is one way we can always use our equation to find more points. Right. Okay, so let's go ahead. Let me make one last statement here. So in general, a circle of radius r and center h comma k, this has the equation it's r squared is equal to x minus h squared plus y minus k squared. Right, we saw this in our above example, that here we see the radius squared, we see x minus that -2 squared, and y minus that 1 squared. Okay, and so let's go ahead and do the reverse, and let's sketch the graph of the equation of some circle. Right, so here we have x minus 3 squared plus y plus 4 squared is equal to 9. And so notice that we can identify the center of our circle as (3, -4). Right, notice that it's sort of the opposite signs here of our -3 and our +4 because we have the subtraction that comes from the distance formula that's sort of incorporated into this equation. And then next we see that the radius is 3, right? That 9 is the radius squared, and so our radius is 3. And so here to sketch out this picture, we know that we have a center of 3, -4, and we have a radius of 3. And so here, how do we sketch this out? Well, that just means that we know that there are a few points that we can really plot out that are 3 units away from our center point. And this, maybe I didn't pick the best grid to draw here, but maybe I have another point out here, and one last point down here. Here's maybe 6, here's 7. Drawing circles is always a challenge. Okay, so that's not so bad. I'll just draw this point a little bit bigger so it doesn't look like I missed it so poorly. Okay, so that's a sketch of the graph of the circle. Let's do one more thing. Let's determine all of the points with the y value of 2 that are on this circle. And so, we can always do this with an equation. We can kind of play the game of, find x if you know y, or find y if you know x. And so here, what we can do is we can plug in this value of -2 into our equation to find the corresponding x values that make this equation true, that are points, corresponding points on this graph. All right, so here I'm going to go ahead and take x minus 3 squared plus y plus 4, but in this case we're looking at when y is -2 squared. I'm looking for this to come out to 9. Okay, well, I can't do much about that x minus 3 at the moment, but here this -2 plus 4, right, so that's that's positive 2. Right, so this comes out to positive 2. And then we're going to square it to get positive 4. And so this is equal to 9. And then now how do we solve this equation? You might consider expanding out this square and then maybe trying to factor or use the quadratic formula here. But actually, if we isolate this squared part, we can apply the square root formula, right? So, or not the square root formula, but the square root property, and we get, take the square root of both sides, we get x minus 3 is plus or minus the square root of 5. And so this tells us that x is equal to 3 plus or minus the square root of 5. So that's the x values that correspond to the y value of -2 to give us a point on this circle. Right? So here one point is 3 plus the square root of 5, comma -2, so that's 1 point. And then another point is 3 minus the square root of 5, comma -2. Right, so where are these points? What we're really doing here is we're saying, okay, what points on the circle have a y value of -2? It's this point out here and this point here. My sketch isn't the most accurate thing, and so I wouldn't be so certain that it has integer coordinates, and here we've figured out that really there aren't any integer x coordinates here. Really this is the point. Oh, maybe I won't write them out again. But yeah, these are the 2 points that I've highlighted on our circle in blue. Okay, let's do one more problem, kind of in a similar vein. So let's find the intersection points of x squared plus y squared is equal to 16, and f of x is equal to 3 minus x. So x squared plus y squared is equal to 16. Right? This is, again, a circle with center Well, here, maybe you think about it for a moment, and I guess you can't tell me, but take a moment and think about what's the center, what's the radius for this circle. So the center is the point 0, 0, right? I can kind of think of this as x minus 0 squared plus y minus 0 squared is equal to 16. And the radius, well, that's 4. Okay, and so if I want to sketch the circle out, well, hopefully I can do a better job this time. A little lopsided, but not so bad. Okay, so that's the picture here, right? A circle of center 0, 0, and a radius of 4. And then we want to go ahead and sketch the graph of this other function, f of x is equal to 3 minus x. So this is equivalent to the equation y is equal to 3 minus x. And here we can see that it has a y-intercept of 3, a slope of -1. Right, so maybe a nice picture to have here is this one. And we're looking for these points here. Right, and it's clear to us, at least from this picture, that they're not quite friendly coordinates, friendly points, but we can work this out, right? So we can use substitution here to take our expression for y, right? Y is equivalent to 3 minus x, and to sort of solve the system of equations where we input 3 minus x for y into this other equation, right? So here we can solve this system x squared plus y squared. Well, y is the same as 3 minus x. Right, so y squared is equal to 16. So if we could solve this equation, then we'll find the x values of these points. Right, so here, I can solve this like a typical quadratic equation. I can try and use the quadratic formula if necessary. And so here we've got x squared plus 9 minus 6x plus x squared if we expand that out. And so I can combine like terms to get x, or 2x squared. I've got minus 6x. If I subtracted 16 from both sides, I would have minus 7 is equal to 0. And this doesn't quite factor so nicely. And so I'm going to go ahead and use the quadratic formula here to give us x is equal to negative b. Right, so 6 plus or minus the square root of b squared. So b squared is 36 minus 4 times a times c, all divided by 2 times a, or in other words, 4. And so notice that this part here, this 4 times 2 times negative 7, well, 4 times 2 is 8, and 8 times negative 7 is negative 56. And if I'm going to subtract that, this is really the same as adding on positive 56, right? This is 6 plus or minus the square root of 36 plus 56, all divided by 4. And so we get x is equal to 6 plus or minus the square root of 36 plus 56. So if I add on the 6, I get 62. And if I add on the 30, I get 92. Okay, we're almost there. So here, I know I can sort of simplify this square root part by pulling out this square factor of 4. Right, so here 4 goes into 92. How many times? I know 4 times 25 is 100. So that means 4 times 24 is 96, and 4 times 23 is 92. So this gives us 6 plus or minus, actually maybe I'll write it out. I'll write it out here. So the square root of 92, this is the same as the square root of 4 times 23, and that's the same as the square root of 4 times the square root of 23, which is 2 times the square root of 23. Right? We can break apart square roots along multiplication or division. And so this is the same as 2 square root 23 divided by 4. And then now we can do this division by 4, right? Whenever we see this, we're dividing this sum here, we really ought to divide both terms, or all the terms. It's kind of like distributing that division. Another way we can kind of maybe more clearly see what to do here is we can factor out a common factor of 2 in the numerator to get 3 plus or minus the square root of 23 over, maybe I'll write it as 2 times 2, and I can cancel out this factor of 2, right? Now that the numerator is factored, the denominator is factored, and they have a common factor of 2, can cancel them out. So this gives us that the x-coordinates where those two graphs intersect are at 3 plus or minus the square root of 23 over 2. Right, so those are the x-coordinates. We actually still need the y-coordinates. We need to plug these back into our function, right? Either function, it doesn't matter which. And maybe the simpler one is to use the second one here, right? F of x or y is equal to 3 minus x. And so here, we know that one point is 3 plus the square root of 23 over 2. And one point has the x-coordinate 3 minus the square root of 23 over 2. And we're saying that the y-coordinates, they're going to be 3 minus that x value. Right, so 3 minus, because f of x is equal to 3 minus x is one of the graphs we're trying to, one of the equations of the graphs we're trying to intersect. We know that we can get the y value from this function. And so 3 minus is kind of a doozy. Right, that's going to be one y value. And this is going to be another y value if we take 3 minus the other x value. So maybe I'll just write y1 here and y2 here. Okay, so that's the other y value, or those are the y values. These are the points of where our two curves, our two graphs overlap.